1 times 2 to the second power, so that's times 4, so I'm going to change that to a 4. That's ugly. So yeah, and then times x minus 1. 2 minus 1 is 1, so there you go. There, that's the second term. This is so easy. Third term, plug it in, see what you get. So it says find the first 3 non-zero terms. Find the first 3 non-zero terms and the general term. Well, we have the general term, so plus dot 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 plus the general term, which is just this. And I think that's it. Yeah, that's it. So there is my answer for that one. Part B, still very easy. This is going to be quite a long video. And then part C. Now this part is the tricky part. I think each one of these are worth 3 points. So hopefully you could get 6 points easily. And then this part, maybe it takes a little bit of time and maybe you don't finish. Maybe you do. But because you've done it so much, you could be awesome on the AP test. Of course, of course, of course. So the Taylor series for f prime about x. So that's actually what we just found. Found in part B, that's what it says, is a geometric series. What? They're saying that this is a geometric series. Now it doesn't look like it at all. So I'm going to finagle with it, I think. I'm going to haggle with it to bring down the price. That's bargaining. Not haggle over the, okay, whatever. Find the function f of x to which the series converges. Wait, what? Find the function f prime to which the series converges for x minus 1. So converges for that radius of convergence. Use the function to determine f. What? So it means find f prime with a formula. So you look at this, use the fact that it's geometric, and write the formula. Okay. This involves knowing a little bit, so I'm going to give you paper, but it should be okay. This says, actually, you don't really need to know this, and I'm probably not going to use it, but it says it's geometric, which is, whoops, you cannot see that, which says it's this, because this is a geometric series, and it sums up to that. So that's the actual function. It's saying find whatever this part is for the series that we have. What we have actually is closer to this, but it starts at 0. So maybe I could use this. I don't know which one would be easier, to use this and show you guys, or to use this and show you guys, because either one will actually work. The first time I did it, I just used this one, because, in fact, yeah, I think I'm going to use this. I'm going to try and do it without having this memorized. Is this right? Okay. Just double check here. Alright, here's what I do know, though. It says it's geometric, right? In the problem, it says that this series is geometric. Now, for me, I'm thinking of the crayon series. So that's like if we have something n equals m, where we have c times a common ratio raised to the n power, and it goes to infinity. So this is a geometric series, and if r, the absolute value of r is less than 1, then this series converges, and it converges to 1 over 1 minus r. So actually, what I'm going to do is I'm going to attempt, actually this converges for absolute value of r less than 1. There, that's the geometric rules. It's telling me that this is true for this green thing over here. It's like, what? What do you mean? So actually, I'm going to try and make it look kind of like this. Try to make it look like this, where I only have powers of n. That's the goal. Because right now I have n minus 1 and n plus 1. Maybe it will be more understandable if I have all powers of n. Then whatever is the base for those for that exponent, that's what r is, and hopefully that's like something. And then whatever doesn't have the exponent, that's what c is, because they told me it's geometric. Hopefully that makes sense. I'm going to say it one more time. I'm going to try and get everything so that I have exponents of just n, and whatever whatever the base is for those exponents, that's what r is. And whatever doesn't have any exponents, that's what c is. So the first thing I'm thinking is like, oh, that n minus 1, that's not nice to me. But I know that it looks like this, so I can start it anywhere, really, where m is just 0 or greater, maybe. Technically, I could start it anywhere. So if I chose this, the first thing when I plug this in, watch this, look at this, guys. I can easily change, I'm jumping around a little bit, but I can easily make this n without any problems, because this -1 to the n plus 1, that's just -1 to the n times -1. So this is part of my c, easy. And this is part of my r, easy. And then here, I'm already settled with that. But this, that's causing some problems for me. And if I wrote it like this, xcn divided by x minus 1, then, okay, so this is part of my r, but then also x minus 1 is part of my c. That kind of makes me uncomfortable. I might be able to do something like that, but I don't like it. I'd rather not have something that's in my r and in my c. I'd rather have it just in one or the other. And there's a way I can do that. So that's what I'm going to show you right now. Let me get rid of this. When I plug in my n, when I plug this in, I get 1 minus 1. That's 0, right? It's 0. So, like for my first term, if I plugged in 1, I get 0 there. Well, I can adjust my my n value here. So n equals something all the way to infinity. All the way to infinity. Okay. So suppose I want this to be a regular n. So if I have x minus 1 to the n, right? Okay. I want it to be that. Remember, that's because that division part I don't like. So I'm trying to get the x to just have a power of n, and I'm going to move my starting place just to make sure that that works. So if I plug in 1, the exponent here becomes 0. So if I want the exponent here to still be 0 for my first term, like when I plug in 1, I will get my first term. Well, if I want the exponent to be 0, then I can just plug in a 0. Okay, great. Now let's make sure all of these make sense. When I have n equals 1, then I have 2 to the 1. So what do I need? 2 to the, if I plug in 0, that's just n plus 1, right? Because now I plug in 0 and I still get 2 to the 1, 2 to the 1, even though I'm plugging in from a different starting place. And then a similar idea for this. If I plug in 1, I want to get 2 here, right? Well, that's just -1 to the n plus 2, right? Plug in 0. So now my first term here, I get, plug in 1, -1 squared. And then times 2 to the 1 times x minus 1 to the 0, right? That's my first term for this green summation. And then my first term here is, well, -1 squared times 2 to the 1 times x minus 1 all the way to the 0 power. Okay, they're the same. They're the same first term. These are actually equivalent. They're fine. I just adjusted the justice. No, I just adjusted the index there, the starting place. So this is fine, and the whole goal of that was so that I could just have my x term to a just n rather than n plus 1 or n minus 1. Because if I had the n plus 1 or the n minus 1, I get x in my r and in my c. And I don't want that. And this is a long explanation just so that I can make it look more like this. Now I can finagle with this, because those are just numbers. Finagle, haggle, bargain, Jarvin equals 0 to infinity. Okay, so this part, that's the same thing. -1 to the n plus 2. That's the same thing as negative 1 to the n times negative 1 squared, which goes away. So this is just negative 1 to the n. Oh, interesting. And then 2 to the n plus 1 is the same thing as 2 to the n times 2. So I'm going to say times 2 to the n times 2. And then x minus 1 to the n. Remember, way beforehand, I wanted all just n's. That's what I'm doing here. So I get the sum. And anything with an exponent of n, I'm going to group together. So I get negative 1 times 2 times x minus 1. All of that raised to the n. Anything not is there. So I have my r value, my r value, and my c value. Oh, wait a minute. This is my first term. Sorry. First term. First term. Not 1. Geez. That was a wrong answer. First term, not 1, but first term. Whew. Okay, so I have this. I'm going to simplify it a little bit. And there we go. So I know this converges to first term over 1 minus r. So what's my first term? Well, if I plug in n equals 0, this goes to 1, and I just have 2. Okay? And then 1 minus r, which is negative 2 times x minus 1. Technically, we are done with finding f prime of x. There we go. There we go. It says find f prime. We did that. And then use the function to determine f. All right, so I guess I'll simplify this a little bit. This is a long video.